Now we're going to finally get to Laplace the method. I want to remind you of the formula for the Laplace of the derivative. The Laplace of the nth derivative of f is equal to s to the n times the Laplace of f minus s to the n minus 1 times f of 0 minus s to the n minus 2 times f prime of 0 minus dot 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 minus the n minus first derivative of f at the 0. And all these f's are the original function. This is the Laplace of the function. So I have two examples here, and I want to do this one first. First step number 1, I'm going to take the Laplace of the whole thing. Now notice, this is an IVP. I have initial values because I'm going to need those when I take the Laplace of derivative. So I'm going to take the Laplace of the whole thing, of both sides. What I do to one side, I must do to the other. Now, let's just go ahead and take the Laplace of this right-hand side. Now think about it. This is the what? First shifting theorem. Okay? So I'm going to take the Laplace of t cubed. Well, think about it. What's the Laplace of t cubed? Well, the Laplace of t cubed is 3 factorial, which is 6 over s to the 4th. But the fact it's the first shifting theorem, instead of writing s to the 4th, I write s minus 2 to the 4th. So that's the Laplace using the first shifting theorem. Now, what's the Laplace of a sum or a difference? It's the difference of the Laplaces. So this equals Laplace of y double prime minus 4, the Laplace of y prime, plus 4, that's the Laplace of y, so let's just put a capital Y of s, and that equals 6 over s minus 2 to the 4th. Now, let's use my formula here. So this would be s squared times the Laplace of y, that's my unknown function, minus s times y to the 0 minus y prime to the 0 minus 4 times quantity. So now n is 1 in this case. So this would be s times capital Y of s minus y of 0, small y of 0, plus 4 capital Y, and I'm just going to write capital Y now, equals 6 over s minus 2 to the 4th. Now let's plug in my initial conditions. So this one, it's very easy. This is 0, this is 0, this is 0. So what do I get? I get s squared times capital Y, 0, 0, minus 4 s capital Y, plus 4 capital Y, equal to 6 over s minus 2 to the 4th. So now that I have that, let's put all my y's together. Okay? So I've got s squared minus 4s plus 4 times capital Y, I'll go ahead and put the s in there this time, 6 over s minus 2 to the 4th. Well, let's look at that. What do we got? Well, what's s squared minus 4s plus 4? This is just s minus 2 quantity squared, isn't it? So I'm going to divide both sides by s minus 2 quantity squared, so I get capital Y of s equals 6 over s minus 2 to the 6th. Well, if I were to look on the Laplace transform chart, it's not exactly how I need it. Since this is a 6, if you remember what I did here, I need 5 factorial. So here's what I suggest we do. Let's write a 6 right here. Let's write a 5 factorial here. S minus 2 to the 6. But since I multiplied by a 5 factorial, I must divide by a 5 factorial. Well, what is 5 factorial? 5 times 4 is 20, times 3 is 60, times 2 is 120. And of course, times 1. What's 6 over 120? Well, that'd be 1 over 20. So, that's what I have. Well, now take the last step, now that I've solved for y of s. So let's remember, first step, take the Laplace transform of everything. Second step is I solve for y of s. Third step, final step, take the inverse Laplace. So what do I get here? I get y of t, because the inverse Laplace of y of s is y of t. Well, what's the inverse Laplace of this? Now I've got it in the form I need it. So it's 1 over 20. 5 factorial over s to the 6, again, is what? Yes, that's t to the 5th. But I've got this shift here, s minus 2 instead of s. So it's t to the 5th, but it's shifted. So first shifting theorem, that would be e to the 2t. So there's my final answer, 1 over 20 times t to the 5th times e to the 2t. Let's take a look at this one. Y double prime plus 4y equals sine t times the unit step function at 2 pi with the initial conditions y of 0 equals 1 and y prime of 0 equals 0. Now, first step, take the Laplace transform of everything. If you don't mind, since I know Laplace is linear, the Laplace of a sum is the sum of the Laplaces, and I can factor constants out, I'm going to have Laplace of y double prime plus 4 times the Laplace of y equals the Laplace of sine of t times the unit step function at 2 pi. Okay, now let's plug into our formula here on this side. So this would be s squared times capital Y of s minus s times y of 0 minus y prime of 0 plus 4 capital Y of s equals the Laplace of sine of t. Well, this is the second shifting theorem because of the unit step function. So the Laplace of sine of t is 1 over s squared plus 1, but since it's times the unit step function, I'm going to multiply by e to the minus 2 pi s. That's the second shifting theorem. Now, let's plug in our initial conditions. Y prime of 0 is 0, so that guy is 0. Y of 0 is just 1, so let's put a 1 in there. So what do I have here? Let's solve for y of s. Step number 2. I finished step number 1, now step number 2. So I've got s squared plus 4 times capital Y of s. That takes care of that guy and that guy. I'm going to take this minus s right here over the other side. So this becomes s plus e to the minus 2 pi s over s squared plus 1. So what do I get? I get capital Y of S equal to S, divide everything by S squared plus 4, so this would be S over S squared plus 4 plus e to the minus 2 pi s over S squared plus 1 times S squared plus 4. This one I can now take the inverse Laplace of, this one right here. This one though, the second one, you know what I'm going to have to do? Our favorite, partial fractions. Now what I would suggest is forget the e to the minus 2 pi s, and I'm going to set up the partial fractions over here. So 1 over S squared plus 1 times S squared plus 4 is equal to AS plus B over S squared plus 1 plus CS plus D over S squared plus 4. Cross multiply now by the denominator, so I end up with 1 equals AS plus B times S squared plus 4 plus CS plus D times S squared plus 1. So that's what I end up with. So let's multiply everything out. So what do I get? I get 1 equals, let's do this one first. So this would be AS cubed plus 4AS plus BS squared plus 4B plus CS cubed plus DS squared plus CS plus D. I went ahead and put that in order. So this is equal to A plus C times S cubed plus B plus D times S squared. So I've taken care of that, I've taken care of that, I've taken care of that one, I've taken care of that one. Let's take care of this one. So this would be plus 4A plus C times S, and then finally I have 4B plus D. So now that implies there are no S cubes over here, so A plus C equals 0. B plus D, same reasoning, equals 0. Same reasoning, 4A plus C equals to 0. And 4B plus D equals, finally got one, that equals 1. Now, thing I noticed, these two only have two unknowns in them. They have an A and a C. So A equals negative C. So this one becomes negative 4C plus C equals negative 3C equals 0. So C equals 0. So if C equals 0, what does that mean? A equals 0. So that's nice. Now I have these two. So let's use this. B equals a negative D. So this one equals negative 4D plus D equals 1. So negative 3D equals 1. So D equals a negative 1/3. So B equals a positive 1/3. So we've done our partial fractions. So what do I have here? So I have Y of S equals, I'm just going over here, S over S squared plus 4 plus, I'm going to factor out an e to the minus 2 pi s times, now what I'm going to do is I'm going to plug in right here the A's, the B's, the C, and the D. Well, again, the A and the C were both 0, so those are out of there. The B was a 1/3, so this is 1/3 1 over s squared plus 1. D was a minus 1/3 over 1 over s squared plus 4. Now, I'm going to take the inverse Laplace. This one's easy. This one's okay. I'm missing a 2 here for the formula, so I multiply by a 2, but if I multiply by 2, I must divide by 2, so that 1/3 becomes a 1/6 now. So I multiply by 2 divided by 2. So what do I get for my final answer? Take the inverse Laplace, the last step. Y of t, well, what's the inverse Laplace of s over s squared plus 4? Well, that's cosine 2t. Now, plus, I know this is the second shifting theorem, so u of 2 pi t, u sub 2 pi of t. Now, this would be times 1/3 sine of, now, that's usually sine of t. But second shifting theorem, I don't put t, I put t minus 2 pi. Minus the 1/6, I'll put it underneath. This again, that's the inverse sine of, inverse Laplace of sine. So that would be sine of 2, should be 2t, but second shifting theorem, instead of t, I write t minus 2 pi. And put a bracket. So you can leave it like that, and that's our final answer. So what are the 3 steps? First step, take the Laplace transform of the differential equation. Second step, solve for the Laplace transform of the unknown function. Third step, take the inverse Laplace.